So we've been talking about circles, and like this says, we're skipping all the way to lesson 10.7. So what lesson did we do yesterday? Does anyone know what number? 10.2. Yep, so we're skipping to the end of this chapter, and we might add a couple things to our chapter 10 learning tomorrow, but we've looked at the bulk of what we want to get out of chapter 10 after we learn about circles. So circles in the coordinate plane. Now, you guys tell me, what is the coordinate plane? What is that referring to? What? What is the coordinate plane? What? Oh, our xy axis. Yeah. Like this. So far in the coordinate plane, you guys have seen, oh, I shouldn't put those. You guys have seen lines. You guys have seen parabolas. You guys have seen square root functions. You guys have seen, let's see, what else have you seen? Oh, you've seen a piecewise. I'm not saying you remember, I'm saying you've seen. What other types of things in the coordinate plane have you seen so far? The one that goes down. Oh, upside down. Whoa. Okay. A negative parabola. What else have you seen? Anything? Any other types of things in the coordinate plane? I don't think so. Well, today we're going to look at a circle in the coordinate plane and what that equation looks like and how we come up with that, how we can manipulate it, all that good stuff. So it's pretty sweet. Now, your warm-up. Find the distance between 2 points. We should have used the distance formula. If we say we have x1, y1, x2, y2, we would go with, let's see here, -1 minus -5 squared plus 3 minus 6 squared. This would be the square root of -1 plus would be 4 squared plus 3 squared, 16 plus 9, and we would get 5. How many of you got 5? Perfect, good job. And we will come back to, we are going to bring back the distance formula a little bit today. So you will need to remember how to use that just a little bit. Our learning target. Students will be able to write and graph equations of circles. That's all we're looking at. We're going to look at a couple definitions, what our formula should look like, and then we're going to figure out how we can graph from that formula. So here is, and this is something that you'll want to have written down, the equation right here, and you'll just want to know that that is the standard form of a circle. Now, this is like the one time ever I'll say that you don't have to have that picture down. Like, that could be a little bit helpful, but the main thing that you want to have written down in your notes is the equation of a circle. Now, if we look at this equation, right, we have x and y, just like, we've seen because we're working in the coordinate plane. Now, like it says, when we are plugging things in, we're going to plug numbers in for h and k, and that's going to be the center of our circle. We also will plug something in for our radius, which is what we're setting everything equal to with r. Now, what's really strange about this equation that we've never seen before?
There's a lot of variables.
There's a lot of variables, okay, so more than we've seen before. What else? What have all our equations been equal to so far that we've ever learned? Whoops. Yes, they've all been y equals, and then we have something. I think every single one you guys have seen so far, you've had y equals. This one, the circle equation, is not y equals. We're setting it equal to our radius, and we will be able to solve for our radius. So that's one thing that's a little bit different. We have y inside of our regular equation. We're not setting everything equal to y. Does that make sense? It's not something that's going to be super tricky, but it's just something that you haven't seen before. So let's look at this example. Write the standard equation of the circle. Remember, our equation is r squared equals, well, I guess I can go in the same order they did. X minus h plus y minus k, squared, equals our radius squared. So we're going to write two different equations. The first one based on the circle right here. So we know already, if we start to write in with the information we know we have to have an x minus something squared plus y minus something squared equals something squared, right? We need to fill numbers in for r, k, and h. Well, we know that the point h, k just represents where the center of our circle is. So where, looking at the diagram, where is the center of our circle? Right. What? Someone said it. Not like, I just couldn't hear you. Right at 0, 0. Right? It's, let's see, 4 units. 1, 2, 3 units away. From each of those ends. So if we know that our center is at 0, 0, then that means h would be 0 and k would be 0. Now, like I talked about, it's 3 units from the center to one of the sides of our circle. So that means our radius is what? 3. So to simplify our equation, we would just write it as x squared plus y squared equals 9. That's it. Nothing too crazy. So let's see how we're feeling. Number 1 should be no big deal. That's just like the example we did. Now number 2, notice the center is moved, right? We're not centered right around the origin. We're moved to the left 2 and up 5. So that's going to change a few things. So go ahead on your class kick, erase anything that might be on there, and give those two a try.
Erase that.
All right, that's good. That's good. There's only 3. There's a warm up and 3 problems. So
All the work that's on here for me, it was like not in this class.
I don't know. I must have somehow. I don't know how, because the class cake I used, I didn't create a new class cake, but somehow I must have used an old one or loaded an old one in, and then I put the pictures on. So something weird happened. Maybe it was my fault. We'll say class cake just for free. Nice job. Yep, looks good. I'll play music while you guys are working, so the virtual students have something to listen to while they're waiting for me to start again. There we go. Nate, where's our work for the warm-up? No, Nate. You know how to do it? Then at least copy it down when I'm writing it down on the board. Nate 2.0 definitely would have put the work for the warm-up. Or Nathan 2.0. Look, Nick's even doing the work from home. I'm just kidding, because Nick's old work is on here. Yeah, he's doing it from home. All right. Most of you, it looked like, got the first one. You're supposed to do the first one, yes. Oh, boy. All right, that's better. For the second one, remember our standard equation. X minus, and I always mix up H and K.
Just put those numbers into the equation.
Yeah.
And then what? You already got the radius.
So our center is at negative 2, 5. So that means X minus a negative 2 squared.
Do we have to do this before we get our assignment for today?
Yes.
He just made that up.
No, I said that a long time ago.
I don't think so.
Thank you, Ethan. So X minus negative 2 would be X plus 2 squared. Y minus 5 squared equals 49. And this would be writing our equation. 49. That's what I said. And that's all that's all we're doing to write that equation. That's it. The only thing you could do to further try to simplify would be to try to foil that, and that would just kind of make a mess. What? Because you could foil this out and foil this out, but you wouldn't be able to simplify anything because you have X's and Y's.
So literally what you're doing is squaring the radius and that's your answer.
Pretty much. Yep. Plugging stuff in. Don't mess up the negatives. Right? Don't mess up the negatives because the standard form is X minus H and Y minus K. So we need to make sure we keep that straight. But that's all we're doing. All right, let's look at another example. And this is the more, we'll say the more complex ones. The point negative 5, 6 is on a circle with center negative 1, 3. Write the standard equation of the circle. Well, what do we need in order to write an equation? We need the radius. How would we find the distance between those 2 points? Distance formula. Very good. But guess what? These are the 2 points you already did in your warm-up. So what do we already know the radius is? 5. So if it's between these 2 points, we know our equation is like this. We already know that r is 5, our radius is 5, but how do we know which point to use for h and k? Which one is it? How do we know which point to use for h and k?
H and K are the center points.
Well, yep, h is our x value, k is the y value. But how do we know if we should use negative 5, 6 or negative 1, 3?
It's negative 1, 3.
Why?
Because
Because it's the center. Yep, we use the center point for our equation. So we would have x plus 1, y minus 3, and that's the best we can do. Well, we can square the 5. To get 25. Don't sleep. We're not done yet. You still have one more practice problem you need to do, and that's our lesson for today. Once you get all the stars on your class kick, then guess what you get to have? The worksheet. And then once you're done with the worksheet, guess what your next assignment will be? Not quite. Guess. When you're done with the worksheet, guess. Exam review. Or what else could you be working on? What's due tomorrow? Everything. Yeah, test corrections included. So you could be working on test corrections as well. We good? No, the exam review is not due tomorrow. The exam review is not due until right before our exam. Like, you'll walk in and hand in the exam review. So all late work is tomorrow. Yep. The circle, this doesn't count like the circle stuff. The circle stuff, the last 3 lessons we've been doing, that'll be due before our quest on Wednesday. But anything else, anything before chapter 10, I will not take after tomorrow. What? This stuff? You'll talk about circles on the coordinate plane in Algebra 2. That's actually what we're doing right now. So,
Back up real quick so you can see how you did it.
sure. There you go. And I can freeze that, and then I can start looking at your class kicks.